Hi friends, in this one I'm going to show you how to build up a series representation of f of x equals 1 over 4 minus x at x equals positive 1. So we're going to write this as f of x is equal to first 1 over 4 minus x. Now, because this is 1 is a shift of 1 unit to the right. What you need to do is you need to transform the expression to express that fact. So I'm going to write this first as 1 over 4 minus 1 minus x plus 1. That's allowed because negative 1 with positive 1 added will give you a 0. I'm not changing anything, just making it look different to the eye. From there, it's going to be like this next. 1 over 4 minus 1 is 3, and then minus x plus 1. Then from here, between negative x and positive 1, you pull out a negative 1. So it's going to be 1 over negative and then x minus 1. This is close, except we need to have a 1 in that position. So for that reason, I'm going to pull this out as follows. I'm going to put a 3 minus, and then x minus 1 over 3 times a 3 in here. This is allowed because this 3 on the top there, divided with the 3 in the bottom is 1, and it would give back the previous step, you see? In other words, this is just multiplying by a form of the number 1. Just like back here, all I really did is I added 0, you see? But doing it the right way advances us in the positive direction towards the solution. So, and then from here, let's pull a 3 out of each term in the bottom. So it's 1 over 3, and then brackets 1 minus x minus 1 over 3 this way. I should stop for a second. You may think that the original 1 over 4 minus x is somehow different from this highly transformed version. Not really, take a look. And I know that. You can check it bulk or wholesale if you like. Now you might think that this 1 over 4 minus x is different from this seemingly highly transformed version, but it's not. Take a look. You can confirm it wholesale, so to speak. Just do a graph of the two. I'm going to graph 1 over 4 minus x. Remember, we are doing our expansion around x equals 1, which is right here. And I'll put in this transformed version that says 1 over 3 and then brackets, and then 1 minus, and then x minus 1, this thing divided by 3 this way. Graph that version. And when you do it, you see it looks like the same two graphs. You cannot tell them apart. In other words, I know this looks different to the eye, but it's not really different, you see? It's just different from the perspective of now, take a look. You can keep the 1/3, and the rest of it you can be expressed in summation notation as n goes from 0 to positive infinity of the following. Here you can put that expression in yellow, x minus 1 over 3, and raise it to the n. Then you can bring that inside, so it's going to be the summation as n goes, so let's see here, from 0 towards positive infinity of 1/3 for now. And then x minus 1 raised to the n over 3. And then the summation as n goes from 0 to positive infinity of the following. X minus 1 to the n over. On the bottom, you see, I meant to put 3 to the n here. That's my fault. So it's going to be here then 3 to the n plus 1. 3 to the n plus 1. That's the summation form of the series representation of the function. We should check the interval of convergence. So the easy way to do that always is you take this expression, x minus 1 over 3, or whatever you've got there. So in my case, I'm going to put x minus 1 over 3, and you set it less than 1. Then you multiply both sides by 3, because 3 is already positive. You can just cancel it off by multiplying both sides by 3. So it's going to be an absolute value, x minus 1 less than 3 on that side. And then break this up into negative 3 is less than x minus 1 less than 3. And add 1 everywhere, so it's negative 3 plus 1 less than x less than, negative 1 plus 1, and then 3 plus 1. Negative 3 plus 1 is negative 2. Negative 1 plus 1 is 0, so you have x. 3 plus 1 is 4. This is then the IOC, the interval of convergence. Lastly, just to convince ourselves rather, that this actually represents the function, we should actually try to write out 3 or 4 terms and make sure that when we plot the polynomial version that it matches the graph correctly. So to do that, set n equal to 0 as an example, and then set n equal to 1, and then set n equal to 2. So let's see here. When n is 0, you plug it in here. So it would be n is 0. So it's x minus 1 to the 0, which is 1. N plus 1 is 1 in the bottom, so it's 1 over 3 this way. It's 1/3. When n is 1, it doesn't affect the x, you just leave it. It's going to be x minus 1 to the first, over 3 to the 1 plus 1, which is 2, so 3 squared is 9. which is going to be, in other words, x minus 1, like this. Let me fix that, over 9. Let's do one more here, n equals 2. So plus, when n is 2, it's going to be x minus 1 squared. And then it's going to be there 3 to the 2 plus 1, which is 3. 3 to the third is 27. And you get 27 in this position. Supposedly, this should match the graph at x equals 1. That's the purpose of doing all of this. So, take this. I'm going to punch it in. It should show up in red there. So you see I'm punching it in, hit enter. And notice that the graph really does represent the function around x equals 1 very well. Let me just improve the zoom here. It should be more like this. You see at x equals 1, they overlap perfectly. And then from here, let's take a look at a problem that series possess. You see, if you look at the original function, it's 1 over 4 minus x. If you replace x with 4, it would be 1 over 4 minus 4, which is 0. 1 over 0 is not defined. In other words, the original function has an asymptote. To visualize it, let me just zoom out on the graph. Do you see how the original function right here at 4 has an asymptote? It's that vertical line. Notice that our approximation using 3 terms, however, goes right across the asymptote. So while this is good for representing the function around x equals 1, it shoots off on the left and right. And here, there is no asymptote. So that information about the original is lost. That's it for this one then. Thank you. Please leave a like and subscribe. I hope it's been helpful. I will see you in another video.